You're welcome to today's video. So today we'll be solving the question that is appearing on our screen. And I believe that we can see the question. The question is question 1, 2, 3, 4, and 5. So I'll be solving this question now, starting from number 1 to number 2 to number 3, 4, and 5. So let's go to our whiteboard screen. Question, I believe you can see the first question, and it says, given the diagram below, we should find the diameter of the diagram and also should find the area of the diagram. And the diagram itself, we are given the radius to be 28 centimeter. So we'll be solving that question now. 2 multiplied by 28 centimeter, and D will be equals to 2 times 28 is 56 centimeter. So therefore our diameter is equals to 56 centimeter. So we want to find the radius, the area of that diagram below. Like we know, the area of a circle is given by pi r squared. But if you look at the diagram that we have there, the diagram is not a complete circle. It is not a complete circle. It is what? 3/4 of what? Of a circle. So if you want to find the area of that diagram, the area is given as A is given as 3/4 multiplied by the area of a circle, which is pi r squared. So the area of the diagram is 3/4 pi r squared. So that means our area will be 3/4 multiplied by, we know that our pi is 22/7 multiplied by r. Our r is 28, so we have 28 multiplied by 28. So let's cancel out 7 here 1, 7 in 28 is 4. Also, 4 can cancel 4. At the end of the day, our area is going to be equals to 3 multiplied by 22 multiplied by 28. So area is equals to 1848 centimeter square. So which means the area of the diagram is given as 1848 centimeter square. So, and that is the end of question 1. So we move down to question 2, and in the question 2, we have that we are told to find the curved surface area and the total surface area of the diagram below. And so we are going to solve the question by using the total surface area of a cylinder when both ends are closed, because in the question it is not indicated that the cylinder is open at one end. So we are going to be using the total surface area of a cylinder when both ends are closed. And the total surface area of a cylinder is equals to 2 pi r into bracket r plus h. So that is the total surface area of a cylinder when both ends of the cylinder are closed. And like we know, the radius is given by 3.5, and the radius is given by 3.5, and our h is given to be 10 centimeter. So now let's do that. We have 2 times 22/7, which is our pi, times r, which is 3.5, into bracket 3.5 plus 10. So that will be equals to, we can write this as 2 times 22/7 multiplied by, now this 3.5, we can write it as 35/10 into bracket. Now 3.5 plus 10 will give us 13.5. Now we can cancel out some things here. Now 7 here 1, 7 can go in 35 is 5. 5 here 1, 5 can go in 10 is 2. 2 can also cancel 2 down here. So at the end of the day, we are going to be having the area to be 22 multiplied by 13.5. And 22 multiplied by 13.5 is going to be equals to 297 centimeter square, which is the area of the cylinder when both ends are closed. As well, we can find the core surface area of the cylinder. We know that the core surface area of the cylinder is given by 2 pi RH. So we have this to be 2 times 22 over 7 multiplied by our R is what? 3.5, which we can write as 35 over 10, So which you can write as 35 over 10 multiplied by our height is 10 centimeter. Now let's cancel out. We have 10, we'll cancel out 10 here. 7, we'll cancel out 5, we have 5. At the end of the day, we are going to be having 22 multiplied by 2 multiplied by 5, which is going to be 220 centimeter square. So we have the curved surface area to be 220 centimeter square, and we have the total surface area to be equals to 297 centimeter square, and that is that for that. So we are going to the question 3. We are going to the question 3, and question 3 we have that so I'm trying to erase this so that it says a cylinder has a diameter of 20 centimeter and height 10 centimeter, is made of cardboard. Use the value of pi to be 3.1. That is, using the value of pi to be 3.1, we have to calculate the total surface area of the cardboard needed to make a cylinder open at one end. In this question, what they are asking us to find is that we are asked to find the area of the word cylinder, or area of a cylinder when one of the end is open. And the area of a cylinder when one of the end is open is given by pi r into bracket r plus 2h. Pi r into bracket r plus 2h. And in the question, we are given our radius, our diameter to be 20 and our height to be 10 centimeter. So our radius is going to be what? Diameter, that is our d divided by 2, which is 20 divided by 2, which is 10 centimeter. So that is the value of our radius. We are given the height, h, to be equal to the height is given to be equals to 10 centimeter, correct? So that's the value of the height. So height is given to be 10 centimeter. So we are told to calculate the area of the cylinder when one of the end is open. So using the formula which says A is equals to, that is the area is equals to pi r into bracket r plus 2h. So that is the area of the cylinder when one of the end is open. So our area A is going to be equals to 22 over 7 times r. Our r is 10 multiplied by into bracket 10 plus 2 times h. Our h is also 10 centimeter. our age is also 10 centimeter. So calculating that, we have this to be equals to 22 multiplied by 10 multiplied by 30 all divided by 7. So that will be equals to 22 multiplied by 10 multiplied by 30. So that will be equals to 6,600 all divided by 7. So that will be equals to 942 that will be 942.86 centimeter square. So which is the area of the cylinder, or the area of the cardboard needed to make a cylinder open at one end. And that's the solution to question 3.